In this video, I'm going to show you how to find the differentiation of hyperbolic functions. So this is the differentiation formula of hyperbolic functions. You don't have to remember or to memorize this function because this formula, because this will be given to you and you just have to understand, or you just have to know how to find the derivative of the hyperbolic function. Okay, I will give you example and also the solution for each question, and you can also try the question and you refer to this this table, formula table. Now let us try this example. Find the derivatives of the following functions with respect to x. You can try this on your own first, and I will show you the solution of these derivatives in the next slide. This is the solution for question A. The first method that I'm going to show you is to use the chain rule in order to solve this function. So we have a function of 2x minus 5, which is inside the function of sine hyperbolic. So first we represent the function of 2x minus 5, which we represent it as a function of u, where u is equals to 2x minus 5. So from here we can find the derivative of this, where u is in terms of x. So du will be over dx is equals to 2. So now what we left is y is equals to sine hyperbolic 2x minus 5, where 2x minus 5 is now is equals to u. So this will be sine hyperbolic of u. So dy over du, why is it over du? Because y is in terms of u. So the derivative of sine hyperbolic of u is cos hyperbolic u. So the next step is to find dy over dx. By using chain rule, we know that dy over du times with du over dx. So we have dy over du is equals to cos hyperbolic u. So we substitute into this times with du over dx, which is equals to 2. So we rearrange this, we get 2 cos hyperbolic of u. But our aim is we want to get y in terms of x. So what we need to do is we have to substitute u with 2x minus 5. So now we have 2 times with cos hyperbolic 2x minus 5. So now the answer is in terms of x. And this is our final answer, where the derivative of y is equals to 2 cos hyperbolic of 2x minus 5. Another method to solve this derivative is using the same concept as the chain rule. However, we use it directly. Okay, now we have y is equals to sine hyperbolic of 2x minus 5. Okay, so we want to find the derivative of y. First, what we need to do is we have to differentiate the outside function and we keep the inside function. So the differentiation of sine hyperbolic is cos hyperbolic, but we remain this function of 2x minus 5. And then we multiply with the derivative of the inside function, which is 2x minus 5. So now we have cos hyperbolic 2x minus 5, and the derivative of 2x minus 5 is equals to 2. Now we have 2 cos hyperbolic 2x minus 5. The concept is the same, but it's just that you don't represent the inside function as u and the outside function as y in terms of u. You can choose any method, it's two methods, that is suitable or that is easy for you. Both methods are correct, as long as the derivative of this is correct. Your solution is correct. Okay, now let us proceed with the next question. Okay, now let us try to solve the derivative of the next question, which is cos hyperbolic to the power of cube of square root of x squared minus 3. I will rewrite this question as cos hyperbolic of x squared minus 3, where this cos hyperbolic is to the power of cube. As you can see here, we have 3 inner function, where the first inner function is x squared minus 3. The second inner function involves the square root of this function. And the last inner function involves cos hyperbolic of this function. And the last and y is equals to this function to the power of 3. So now we can represent the first inner function, which is u as equals to x squared minus 3. Then we find the derivative of u, where this u is respect to x. So du over dx is equals to 2x. The next one is we have to represent v is the square root of x squared minus 3, where square root of x squared minus 3 is now square root of u. So the derivative of dv over du is equals to 1 over 2 u to the power of 1 over 2 minus 1, which is equals to u negative half, or we can write it as 1 over 2 square root of u. Okay, the next one is, so we have represent this function, and we have another one which is cos hyperbolic. We represent it as w, cos hyperbolic of all this square root of x squared minus 3, which is cos hyperbolic of v. So dw over dv is equals to sine hyperbolic of v. And the last function we have is, of course, y, which is equals to, all of this is equals to w to the power of 3. Now we find the derivative of this is equals to 3w to the power of 2. Now we can find the derivative of dy over dx by taking the dy over dw times with dw over dv times with dv over du times with du over dx. So first one, dy over dw is 3w squared times with dw over dv, which is sine hyperbolic of v, times with dv over du, which is 1 over 2 square root of u. Then the last one is du over dx is times with 2x. Now what we need to do is we have to substitute this w, v and u in terms of x. So w is equals to cos hyperbolic of v square sine hyperbolic of v is square root of u times with 2 over square root of u, which is x squared minus 3 times with 2x. Okay, we still don't represent all the function in x. So the next is substitute again cos hyperbolic v, where v is square root of u. So u is x squared minus 3 square sine hyperbolic of square root of u, which is square root of x squared minus 3 times with 2x over 2 square root of x squared minus 3. So we can simplify this with 2, and then I will rewrite it here. So the final answer will be 3 times with x. So we have 3x cos hyperbolic of square root x squared minus 3, where this is square, so we have cos hyperbolic square, times with sine hyperbolic square root of x squared minus 3 over square root of x squared minus 3. So this is the final answer of this question, where this is the dy over dx. Or another method is, so I will rewrite this as cos hyperbolic x squared minus 3 to the power of half. This all is to the power of cube. So first one is we need to differentiate the outside function, which is the cube function, the power function. So and remain or keep the inside function. So first we differentiate to the power of 3. So we get 3 and we keep the inside function, which is cos hyperbolic x squared minus 3 to the power of half. This will be to the power of 2. Now we have solved the outer function. The next one is differentiate this times with d over dx cos hyperbolic x squared minus 3 to the power of half. Okay, now we have here, just rewrite this all, or we can represent this as square root of x squared minus 3 square. So the differentiation of this is, the differentiation of cos hyperbolic is sine hyperbolic. and we will remain the inner function, which is x squared minus 3 to the power of half. Then we have to find the derivative of the inner function, which is x squared minus 3 to the power of half. Okay, the next step, so we can rewrite this back. The power of 2 sine hyperbolic square root of x squared minus 3, and find the derivative of this, where this will be 1 over 2 x squared minus 3 to the power of half minus 1, which is negative half, times with the derivative of the inner function, which is x squared minus 3. So now this will be x squared minus 3 times with sine hyperbolic square root of x squared minus 3 times with 1 over 2 square root of x squared minus 3 times with the derivative of x squared minus 3, which will be times with 2x. So we can simplify this. This will be times 2, and what we left is 3 times x cos hyperbolic, so this can be written as cos hyperbolic square of x squared minus 3 sine hyperbolic x squared minus 3 over square root of x squared minus 3. So this is the final answer of the derivative of question B. So our last question is to find the derivative of square root of cotangent hyperbolic of 5x. So using the chain rule, we will have the first inside function, where we represent this as u equals to 5x. So du over dx is equals to 5. And then we have v, which is equals to cotangent hyperbolic of 5x, which is u. So dv over du is negative cosecant hyperbolic square u. So you can refer to the table given to find the derivative of the hyperbolic function. And the last one is y is equals to this cotangent hyperbolic 5x is equals to v to the power of half. So dy over dv is equals to half v minus half. So now the derivative of dy over dx is dy over dv times with dv over du times with du over dx, where dy over dv is equals to 1 over 2 square root of v times with dv over du, which is negative cosecant square u times with du over dx, which is 5. Substitute v into x, we have cotangent hyperbolic u, where u is 5x, times with cosecant hyperbolic square u is 5x, this is negative, times 5. So we simplify this, we get negative 5 cosecant hyperbolic square of 5x over 2 times with square root of cotangent hyperbolic of 5x. Or if you want to find the derivative directly, first what you need to do is to differentiate the outer function, where you can rewrite this as y equals to cotangent hyperbolic of 5x to the power of half. So we have the outer function is 1 over 2 and remains the inside function, which is cotangent hyperbolic 5x. So this will be half minus 1, which is negative half, and then times with the differentiation of the inside function, which is cotangent hyperbolic 5x. So the next step is, well, this one will be 1 over 2 cotangent hyperbolic of 5x times with the differentiation of cotangent hyperbolics, which is negative of cosecant hyperbolic square, and remain the inside function, which is 5x. And don't forget to differentiate the inside function, which is 5x. So now we have negative of cosecant hyperbolic over 2 times with cotangent hyperbolic 5x times with the derivative of 5x, which will be 5. So the final answer will be this. Okay, as you can see, you can use any of the method that is suitable for you. You don't have to show this all methods. It's just that I have to show to you for you to revise, to do the revision, and for you to understand which method is better for you to use in future. So that's all for the differentiation of the hyperbolic function. So the next will be the integration of the hyperbolic function.